It's not charging battery.
No,
Okay.
it's just to be
Okay,
turned
so
off
good.
wood
Okay.
for the
It's okay.
Give me 1 second.
S-
Say something to the agenda and then
Sure. So good morning, everyone. Almost everyone. Welcome to the third day. So we will start this morning with Marc-Oliver. I think you all know him, right? He's the main organizer of this event. And this morning he will talk about he will do the keynote. So he will talk about IoT security. He just changed the title a few seconds ago. Yeah, so Marc-Oliver and I met a few years ago with this German-French Academy for Industry of the Future. Yes, there's the panel here. And we started to work together on different research aspects. He's also involved in e-learning, so he's very innovative in this way. And currently we are doing a MOOC, so an online course on IoT together that should be ready next year, somewhere next year, I guess, depending on how hard Katharina will push us, I think. So yeah, let's give the floor to you.
Thank you very much, Nicolas. Okay, so as yesterday, brief wrap up what we did. So yeah, this is the agenda from yesterday again, and so we started with the okay. So I'm here. We started with the challenges on around industrial AI, and then we had the hands-on introduction, and then in the afternoon we had the nice talk about the NPU, and then you started working on, yeah, and of course IoT and AI in the industry by Ingo. And then you started working on the challenges, and then as we were so productive, we shortened the city tour a little bit. And today is the main day where you can work on your challenges. We have only 2 talks, so one by Nicolas and one by me. The second talk, we shifted it with the lunch, so we'll have the talk before lunch, and that means that directly after lunch, so we'll go to lunch at 1, directly after lunch, you can continue with the challenges and you won't have an interruption for that. We have today open end, so we will not interrupt you with the city tour again, but we will order some food, we'll get some food in here, we can eat in here, and so you can work today as long as you wish. As I said, we skipped some things in the city tour. So if you are still here for some days, I definitely recommend going to Marienplatz, Viktualienmarkt, the synagogue, Assam Church, Sandlinger Tor. So this is all very close to each other. So you can look it up in the map and walk there a little bit. Theresienwiese we went, so this is where the Oktoberfest is. And in there, there's also this statue that is the Bavaria. It's a bigger version of the one that we saw 2 days ago. And yesterday I was not sure if it's open, plus we were a little late for the restaurant. This is why we didn't walk there. This was actually where we took the traffic light over the street, just a few meters on there. Also a nice spot to go, but if you have less time, rather do the other side, do the other tour. Okay, picture, just as a reminder again, please share your pictures. As yesterday, until short after my talk, you still have the chance to upload pictures from yesterday so that they're in the right folder, and then I will switch to today's folder. Okay, and as promised, so we did the drone shot yesterday, and we can have a look at how it got. And okay, of course, this is happening, because when I just tested it, it worked. When I tested it yesterday, it did not work. So let's try if we can get it running if I just start right here. Of course not. So then I switch to the other application here. Okay. Yeah, so just as a quick preview, so this is how the drone shot got. And so, yeah, I think it got quite nice. Good. Okay, so let's go back to the presentation. And this was it also for the introduction. And now I would switch to the keynote on security. Stream ready? Running? Okay, perfect. Good. IoT security, a very important topic. And yeah, let's start. So the guys in the back, by the way, are Robert Tarjan. So it's not working again. Let me just start this thing once again, because I definitely need the presenter. So it's not working at all, of course. So then I have to get the other presenter. Sorry for that. So whenever you organize something, always have some spare parts, because things will not work as intended. Okay, perfect, good. Then I can at least switch. So security in IoT and AI, machine learning, why is it especially important in that area? Well, just as a brief recap, so we have these spaces, public, private spaces, and as I told you yesterday or 2 days ago, what we can do with software is we can do like magic, so we can orchestrate these spaces, and yeah, so we can do it ourselves, and with machine learning then we can do that algorithms do that, and somehow we can create the matrix today. And of course this brings high responsibility as a software developer. This is also something important I want to talk about today, and I want to start with the motivation. So what do we need security for? Well, we need security for many things, but especially for safety, privacy, and also for reputation. When you think you're an enterprise, it also is about your reputation. Because if something goes wrong with the security, you have bad news. Okay, so safety, also as a brief recap. So these were the guys yesterday or 2 days ago with this nice tool. And so safety is obviously important, because you are controlling with your software things that are physically able to harm people. Okay. Privacy. So yeah, we have this setting, And you see that there's something behind the brain, and we can just move the brain a little bit up, and there's an eye. Because all these devices also, on purpose of course, sense their environment. So they collect a lot of information about you. And when you think about what is the biggest data collector in the past years, maybe you will say Google or Facebook, the sensors are different because Google and Facebook, they typically collect data, okay, Google when you surf, but Facebook, other people put data about you. And so they are the medium to put something. But the sensors, they have absolutely no bias. They are just measuring where you are and putting that online, for instance. And so therefore, the data quality, so the being true of the data, so that is really the data, is most likely much higher, which is then also making it even more important to be aware of where your data goes and what happens with your data. As an illustration for that, I have this here is from China. Why do I choose an example from China? Because China is a very good looking glass in the sense that there the government decided to implement technologies that luckily are not implemented in Europe vastly yet. And it shows us where it can go and where we as a society have to discuss now how we want it to be. If we want to be like that, it to be like that, or if we want to have different situation, want to allow different things. And yeah, so what we see there, I mean, you probably know the examples, is that you can classify the different objects that you have there, and you can give them different parameters. And I also stopped it here because, as you see here, literally, you leave data traces, and they are measuring things here about you. And you can read many articles about that. So this is also social scoring is one of the keywords here. So you can do lots of applications with that. Here we see fixed sensors, but when we look at autonomous driving, for instance, it's also interesting because the cars of the autonomous driving companies, especially the Tesla cars, are based on cameras. And so they're also driving around and collecting lots of data about the traffic lights here, of course, but also about people walking around. You could do that. Someone was even implementing a hack some month ago where he was doing face recognition with every person that was walking around the car. And so this is, again, a powerful tool. And with the technology, we can do a lot of things. And as software developers, we have to be responsible with what we release and what we offer there and what transparency we show the people, like what is happening with your data. Okay, and the third point, reputation, I briefly mentioned it already. So when you have such a headline here, then probably your security team was not doing the perfect job. And when you're the head of security, you're probably not that so much longer unless they don't find someone else. And so therefore, of course, for a company, it's important also to provide security for this reason, so for reputation. There are many more reasons, but very important, security is still not enough a selling argument. So for private consumers, not at all, because they are like, okay, if it's cheaper or if it's providing more functionality, we just agree, so it's okay, you can do whatever you want. And for companies with issues like the one before, it becomes more and more important. But to me personally, it could be even more important, this topic. Okay, so short detour now. Why should you care? Well, it's basically about ethics. And ethics seeks to resolve questions of human morality by defining concepts such as good and evil, right and wrong, virtue and vice, justice and crime. Why do I put this? Because ethics is basically us inside society. How do we want the society to be? What do we want to allow there? And also, as software developers, we're really powerful. We have the magic stick. So we can create the things and people are running it. And they are not the experts. So they cannot look into the AI algorithm, if we even can know what it exactly does there sometimes. And therefore, we have this responsibility. So looking more at us, so what do I personally have to do with that? Well, you have to be aware that back in the 19th century, industry looked more like this. So you had people, they were doing handcrafted stuff. Today, when you look at okay, what is happening? Well, so today, working somewhere more looks like this. and the central entity is the computer. And what is the denominator here? The denominator is software algorithms rule the world. And it's just a fact. And it's interesting to see, because before thinking about that, I was not so much aware of it. But when you think of it, in which devices do you have software running? It's many, many devices today. So these are exactly these cyber-physical systems where you replace physical control things via software. And they do not have to be networked. So they can also be just running, and then it's not working anymore. What should you do there? Well, don't be evil, of course. And yeah, I have 3 examples now where we can just think about, okay, what could be the problem here?
We think AI can help with this problem. So let's go back to this example. Let's say you want to ask Google to make you a haircut appointment on Tuesday between 10 and noon. What happens is the Google Assistant makes the call seamlessly in the background for you. So what you're going to hear is the Google Assistant actually calling a real salon to schedule the appointment for you. Let's listen.
So how can I help you? Hi, I'm calling to book a woman's haircut for a client. I'm looking for something on May 3rd. Sure, give me 1 second. Sure, what time are you looking for around? At 12 p.m. We do not have a 12 p.m. available. The closest we have to that is a 1:15. Do you have anything between 10 a.m. and 12 p.m.? Depending on what service she would like. What service is she looking for? Just a woman's haircut for now. Okay, we have at 10 o'clock. 10 a.m. is fine. Okay, what's her first name? The first name is Lisa. Okay, perfect. So I will see Lisa at 10 o'clock on May 3rd. Okay, great. Thanks. Great. Have a great day. Bye.
So who knew the video? Okay, very good. And so you probably also know then that after this, so this was like 2 years ago, I guess, or last year. And so there was a discussion if it's good or not. And we probably all agree that it's helpful to have that such functionality. But what was the problem? The problem was exactly this, where you also laughed, is, because the AI was unnecessarily imitating being a human, and for the person that was called, it was not at all clear that the person is talking to a machine. And therefore, they also were told to change this, so that is now saying, okay, this is a machine call that is calling, and so this is about transparency. Thinking a little further, I was also reading a headline when I was looking now what I tell here. So there was like, what about machines talking to machines? So think about the Google Assistant is calling the Amazon Assistant, and they are starting the conversation. So interesting idea. Okay, then second thing, yeah, I said looking at China is interesting to see where it can go. So this is not in China, this is in Berlin. And so there, they also tested exactly this. I mean, it's a test, as you can see, because no one rides the escalator like this, looking directly into the camera. But anyways, what they do is that they look for suspects here. So they're observing people, looking at what is happening there. And this is possible through AI because you have fuzzing, and it's now possible to do image recognition without having the exact same picture. And this was not possible 5 years ago. Okay, and the third that you hopefully also heard of is this one. So with these smart assistants, there were multiple articles about it, that there are people paid for listening to what happens with these assistants, and they are not only getting the snippets when you said the keywords, but also when they thought you said the keywords, and there it was that they get to hear a lot of things, and they even have a button to say like, yeah, you should probably not listen to that again because it's somehow private, and you just have to be aware that this is happening, and it's maybe not so good for our freedom in the end, because when you know that you're surveyed all the time, then you might act differently. And so these are $600+ spy devices that we all carry with us. With software, of course, you can activate all the microphone, camera whenever you want, and you can also be sure that this is happening if you're a a good target at least, because it might be costly to do so, but then, yeah. Okay, main message for you as shapers of the future, which you are, because you will be creating the things that will be running in the future. Think about the ethical consequences before you release your algorithms, and that brings me now to the main part, namely, it could be a cool idea to provide you, as the ones who shape the future, with the tooling that automatically takes care of the security aspects, so that you cannot do it plain wrong. Okay, and so what do we have to do for that? We need security and privacy by design. And in the next part, I will talk about how we try to provide this security by design. So first of all, security, so which are properties of security? Typical properties that are mentioned are confidentiality, integrity, availability, and non-repudiation. Briefly saying confidentiality, keeping things secret. So there you can, for instance, do encryption of data on disks, or multi-party, secure multi-party computation. Integrity, that the data is not getting changed without consent. Availability, that it's not going away and then the services cannot run anymore. And non-repudiation, that it's clear especially who changed data and who added data at which point in time. And you can already, as you probably have also a lot of security background, think about what you need for that. And so you will need things like identities, and you will need identities not for people, but also for software. You will need encryption on transport between distributed entities. So the communication has to be encrypted and also authenticated, so the partners have to get to know each other. You need encryption on disk. You even might need encryption when it comes to the processing, like with the secure multi-party computation. You might need something like auditing of algorithms so that you're clear what the algorithms are doing. Even formal verification could be a good idea. And you might even go towards securing the sensors and actuators that we have, so that there are not people coming and changing a few parameters and then later things like steel mills are breaking down because someone changed parameters slightly, and then hardware devices wear it out and we're destroying entire machinery, as it happened in multiple places in the past 10 years all across the world. Okay. This picture I showed to you yesterday already. These were the different shells that make our smart space orchestration, or this IoT AI controls the world, possible. And the interesting thing is that on all this here, we have control, because there is software running on it. And so if we are software engineers, developers, we can do something here. And I want to go now from the inside to the outside and show you how we provide security in these directions. And this is quite good, actually, because this is the whole world in the end, at least the world that we can control. And so if we can protect this middle part here, then outside we have the real world. So we have the humans, and they have to be securing themselves on themselves. So there we cannot do much. I mean, we could even do something maybe, but this has to do then again with freedom and protectionism. So yeah, but all the things in the middle we can protect, and we should do. Okay, let's start in the middle. So in the middle we have the middleware. We heard about it yesterday, and Sumya, for instance, talked about it. And there we have data, communication, we have discovery of entities, and what do we do there? Well, we do identities for software entities, then we do secure metadata and secure data, and then we do access control. Let's start with the identities. So this is, again, the life cycle of a software for a industrial automation scenario, or also a smartphone software. And it's getting developed somewhere, then it's getting shipped to an app store, and from there it's getting shipped to a space, to a production site, somewhere where the software will be running. Okay, and so what do we do to secure that? Well, typically what you can do here is that you use public-private key cryptography, you do hashing over entities, and then you put certificates where you can store this information. Plus, you do something that you authenticate the user and then give the user gives you this public key, and with the private key, you have then the identity of the user checked, because you can authenticate that the developer uses the right identity thing, namely the private key to encrypt the hash, and then you can secure everything on the way from here to here. Certificates are the transportation mean here. So basically what we do is we have a hash inside over all the data that we want to protect, and then we send the entire bundle, and via the certificate it can be checked that the integrity was not changed, and therefore we have the security property that we want here. Why do we need the store? Well, if we wouldn't have the store, then we would have to set up mutual trust with all the developers, and this is a little bit difficult, especially when you want to have multiple developers, and therefore the trust is between the developers and the store. The other way around, of course, so the store is trusting the registered developers, or if it's not trusting them, it at least ensures that they have non-repudiation, so it's clear which developer did something there, and then the different sites only have to trust the store. So this is much more feasible from a management setting. Okay, then what happens? So this one here sends the certificate. The certificate is signed with the private key of this one here. And then to use this one as trust anchor, what we do is we just copy all the data from the certificate and sign it with the private key of the store. And then we have the store as trust anchor and can continue, because then you only need the public key of the store here. Then you can verify everything when it comes in. And then here we do the same game again, because an IoT system is a distributed system, and therefore you have loosely coupled nodes, and they somehow have to know if something was installed or added to their space in an intended way or not. And therefore we do another certificate here that we sign with the key of the production side of our installation here, and then the software entities are shipped to the different compute nodes, and then it can be verified that they are indeed validated when they came in here. You can check if it's still the same executable. You can do the same on updates, and then you're sure through the entire path that you have the real software running that you want to have running there. An interesting aspect, of course, you might have some metadata that you want to change. We also enable that. And you might want to change them over time, and what you can do for that, which is also interesting. At the beginning, when certificates were introduced, probably you know about certificate revocation. So who knows about certificate revocation, what that is? Okay, some of you. So when you browse the internet, for instance, then websites can have certificates, and sometimes people are stealing certificates, or even worse, they're stealing the private key of a certificate authority, and therefore people thought from the beginning, if this happens, we need a way to prevent people from continuing using these certificates. And the typical way how it's implemented in the internet today is that you had certificate revocation lists, and when your certificate comes on that list, then the browser should check if it's on that list, and if it's the case, then it should tell you that it's not valid to use it anymore. So this is revocation, that you ship the certificate and it always has a validity, and then within the validity you can even revoke by having it on this list. When we think about this distributed setting here, of course, this is not such a good idea, because if we don't have connectivity to the revocation list, or we don't have the resources to look at it, then we cannot revoke the rights here, for instance, if someone changed access rights here. And therefore what we do is an idea that was already told at the beginning, namely short-living certificates. And in the real internet, this is not possible because you would have a tremendous amount of traffic. So with the Let's Encrypt, you even have it a little bit, because they typically renew only for 3 months. So then you have only 3 months period at least until it has to be revalidated. But what we do here is that we have certificate lifetimes of roughly 1 day. And that means after 1 day, you only have to synchronize the clocks. And our middleware components, these KAs here, are taking care of checking that the certificates are still valid, and after 1 day they become invalid. And within the site, at least in the place where we have enough bandwidth, we're automatically renewing these certificates here. And so this is a nice mechanism to have a fully distributed revocation. Okay, good. Let's go on. If you have more questions to that, you can ask in the end. I can tell you for hours on this aspect here. Okay, so this one I also showed you yesterday. So this is the game again that we have in the background. And as I told you, we have a data-centric middleware. So this is where the semantics are, and everything is coupled over data nodes. If I want to talk to you, I store it in a data node, and then someone else can access the data node. This is a basic principle. This is a blackboard or tuple space communication. We extended it a bit, but this is the basic principle. Okay. And so what we do now is also straightforward and very simple, but also very, very powerful, because we can do a system-enforced mandatory access control, and we do it in that way that for each of these software components within the certificate, we add access groups, access group IDs. And all these nodes here, they also have the access group IDs, and to access the data of another service, you have to be in the group that is able to access this data. And this is providing the baseline for security, because the developer already has to define what she wants to access later. An example is when you write an app that wants to access cameras, then you would use the group for accessing cameras, and in the site, all the cameras would offer data saying, okay, only those applications that belong to the group cameras can access it, and then on access, it's automatically checked by the middleware that you have these access properties granted or not. And the thing that was on the slide before, where you could do some settings, there you can exactly say that you want to have less access rights. So this is what the user can do. But no one in the entire processing chain can ever add access rights. And so this is quite coarse granular, but also powerful, because it does not allow an application to have more access rights than the developer initially set. And on installation, the user is presented all the access rights groups and has to explicitly select or deselect those that should be enabled or not. And in an industrial environment, this is definitely feasible, because there you have experts installing it. We are also looking at private environments. There it's a little bit more challenging to inform the users so that they can take an informed decision on the security parameters, which is of course important, because otherwise you have the typical scenario that you might have seen with non-computer science friends or even with yourself. Do you want to do this and that to make the application more secure? And then it's a little bit complicated, and the people are reading, do you want the application to run or not? And then they click on, okay, allow everything. And this is of course not good when you think from a security perspective. Okay. Good. So then we have this automatic matching, and no one can trick it because the middleware is taking care of it, and the middleware is our secure zone where we have control. And if we do our job right, then all the third-party developers cannot do it more wrong than having all the access rights there. A good example there was also this application you might have heard of 5 years ago, I think, where there was an application, I think it was a game or something, and it was in Android, and it was asking permission for the calendar and the contacts and everything, and then it was directly uploading it to the cloud. And for the game, you didn't need any of those, but they collected lots of data. And you might also have heard that data is the new oil, meaning having data is being able to make money because you can do targeted advertisements and so on. Okay. Let's continue. Services. Okay, what do services provide? They provide functionality. So these are the algorithms. This is the logic that does something on the data, that does your control, that does your monitoring. What do services also do? Well, they access each other. So as I told you 2 days ago, we have a microservice architecture. That means services are very often talking to each other and connecting to each other. Okay, so what can we do there? Well, as I tell you, we have third-party developers, so we don't know what they do. Of course, we could force them to write a specification, but this is against telling the people, okay, you can be creative, you don't have to be like a programmer who had a training for many years, you can just create something. Therefore, it's unlikely that the people will do such a thing or will be able to do such a thing. And I want to keep the hurdle low so that people can just develop something and send it in. Therefore, again, what we try to do is we try to automate the process of securing this functional security of the services, and their machine learning can be of big help, because what we do there is we try to detect and mitigate from security issues to prevent it in the future. And so basically we do machine learning based modeling of services, and then we sandbox and do anomaly detection. How does that look like? Well, we have the applications, and they are here. So you see already that we move from the core in the middle, so from the data and the middleware, now to the applications, so a little bit more to the outside. And the approach in a nutshell is that we say, okay, we have these services, we take them as a black box, and then we observe the communication. In our case, this is possible because our middleware is managing all the communication, and it's using a REST-based interface, and it's based on semantics. So we have a lot of information of what we want to do there. Now, this is very helpful when you do research in that area, because then you already have everything and you can use this information. In the paper to that, we also show how you can do it when you don't have such a middleware, because you can also, of course, detect all this, but then this is extra work. And as a researcher, it's like, okay, my focus is on this, so I don't want to do such a bunch of extra work to continue with that. And therefore, it's very helpful, the approach that we have there. So we have the black box assumption, then we do passive traffic monitoring. So we look at, okay, who's talking to whom, when. And then we do behavior modeling using the machine learning. So we try to find out, okay, what is the software probably doing at the moment? And then when we have that model, we can do anomaly detection. And then, of course, we can do firewalling. And this one we demonstrated with the setting that you see in the back in front of the screen. So there you can have a look at the box that we created for this demo. And the demo here is, we have a washing machine. The washing machine, of course, has software, and this is not fake. I mean, this is real. So you can see washing machines that tell you, like, okay, I have a firmware update. You want to update now or not? And when you press it, then maybe it's like with these computers, you cannot wash for the next 2 hours. And the demo here was that the washing machine had a firmware update, and then after the firmware update, it started opening the front door, because it was just looking for front doors and opening them. And this is what we demonstrate in the demonstrator in the back. And so what we introduced there is these observation points here. So they're looking at what the software is doing, because the challenge is, of course, you need first some kind of ground truth what the software is supposed to do. And if we don't have an expert team that is creating that, which is not really feasible when you have lots of applications, then we have to do it on site. There's also something interesting, this Google Always Better is also something that makes a lot of sense for the IoT spaces, because an IoT installation is most likely different from all other IoT installations, because you have different sensors and you have different side effects and so on. And therefore, it's also important to look at the installations when you want to do something, especially also with security. And so what we do now is we learn, okay, what are these software instances doing? And then we're using this knowledge, we're combining it, we're using a central entity. This is, of course, also something where privacy plays a big role, because you can, of course, not reveal that I always shower at that point in time and that I'm not at home at this and that time, because it's also a big risk, of course. And then the good thing is, when we do this, after a short time, we know how the software typically behaves in all the sites, and then we can distribute the knowledge to other sites, and they are protected from the beginning. Challenges, of course, okay, how do you adapt to changes, to configuration changes, to updates, and so on? There you have to look at. As an example, which features we look at, this one here. So here you see communication requests from a software. And so when you look at it in a time space here, then you see that the software is sending some requests, so you don't see much. And this is where the power of having these metadata comes in. Namely, you can decorrelate all these requests here by saying, okay, this software component is now talking to that other software component. And when you do that, you can do something that is actually quite simple. Namely, you can do clustering here regarding the periodicities. And then you can use that for the model. You can say, for instance, okay, a battery read happens every 2 seconds. So these are asynchronous reads, so they are no non-periodical reads. So this is why they are at 0. And so here's a periodicity. This one is better because here it's indeed only every 2 seconds. And so we know, okay, if it happens much more often, for instance, then there's probably a problem. And it must not necessarily be a security problem. It could also be that there's just a problem with the software or the hardware got down, but there's an issue. And this is already very helpful. Okay, and so we see decomposing the traffic by using context information, namely who's talking to whom and what are they talking, because you can also look into the packets here. These are interesting properties where you can create powerful models. Okay, good. Then we come to the outermost layer, namely the sensors and actuators, and so they provide you the interface with the physical world. So they provide the interface to the physicality. And what can we do there? Well, we can do, again, anomaly detection and sandboxing, and we can use a tool, namely watermarking, to protect what these hardware entities are doing. And yeah, so this is what we had before, the self-learning application sandboxes, and around that we can now do the watermarking. And what is it? Well, in a nutshell, it means when you have an entity like a valve control, for instance, in an air conditioning system or in some other system that is relevant for your production, then you will typically do some sensor readings. Okay, and what you can do is you can also combine the sensor readings with sensor readings from other entities, and with that one you can already find out if someone manipulated the sensor readings, for instance. Okay, so this is possible. I mean, you just have to deploy more sensors than you actually need, and then you can do such a thing. This is already a good idea. And the other thing is more tricky, because these attacks that were done against facilities that were of high value, they were not so easy to detect, because they didn't change in a way like, okay, now run at 300% and it will destroy you in 1 minute, but they just changed slightly so that the destruction happens over weeks or even months. And this is more difficult to detect. And what you can do there, or what we try to do there at the moment, is that we introduce additional signal components that are much more changing when you do slight changes in some of the properties of the hardware. And if we manage to do so, then this is good, because that means if there is only a little change, we can already detect a big impact of that in our signal. And this is not, again, not only important for security, but it's also important for predictive maintenance, because then you know, okay, something is going wrong, and the part might have to be replaced very soon. So Ingo said yesterday, things that happen typically on Saturday or Sunday, and it's good to know in advance. And so this can also contribute into that direction. Okay, good. So coming to this, the good thing is we can do something. Okay, that brings me to the last part, call for action, as we also heard 2 days ago. So I started with that the security in IoT and AI machine learning is especially important, because we can create the matrix today. Then why is it important? Well, what we do with the technology today is comparable to a certain extent to another big thing that was developed, and it's this one here. And so there were also scientists that were developing something. And the head of the Manhattan Project that led to the development of the first atomic bomb said, after they saw what happened with it, we knew the world would not be the same. A few people laughed, a few people cried, most people were silent. I remembered the line, more. Now I am become death, the destroyer of worlds. Okay, and so I wanted to show you this because it's also now partly in your hands. So you're about to have a discussion in society that I consider very important, also with non-scientists, non-technical people, especially non-computer science people. So we have to get into the dialogue with the society, with other sciences, to discuss about what can we do with this IoT, what can we do with this artificial intelligence, and what do we want as a society. And it's a very difficult dialogue, because when you talk to law people, for instance, this is for me always especially difficult, they tend to see everything in totally different boxes, and they want to put things into specific shapes that are not very familiar for me. And you have other sciences, other humanities, where people have different pictures, and we have to inform them what is happening there, make it understandable to them, get their input, take also their input as something valuable for us, not saying, okay, they are not doing real science, so it's us who knows everything. And we also have to be aware that we really have responsibility for the things that we're creating there. And this is the major take-home that I want you to take from the talk. Think about what you're releasing there, and if you think something is not going right with these algorithms, open your mouth, say something. Because if it's deployed, if we have the mass surveillance deployed and we are getting tracked everywhere, we cannot retract it because no one will stop it. Why should they ever stop it again if it was deployed once? So we have to be aware from the beginning what we want to have there as a society. And it's what makes it even more challenging is that the Internet of Things has this term internet in it, which means we are globally connected. You also already know this, that data is just floating over borders. And when the internet was a new thing, some 20, 30 years ago, then there was a discussion, okay, what happens in the internet? What happens when something happens that is illegal in my country, but it's running somewhere else? And this discussion is still up to date today, because in the internet you don't have the borders. And everything is moving, the algorithms are running somewhere. Just be aware of it and spend some time thinking on it. It's important for us as a society. Okay, so I didn't want to end with a negative picture here. This was just for making it aware that, okay, this is happening. And so therefore, I put again the clip that I showed on Monday. Of course, we can do very nice things. We can protect people by preventing that they crash into each other. And this is exactly what we see here again. And yeah, therefore, what I say is, do the nice things, and if you see evil, at least raise your voice, make the people aware of that there's room and need for discussion. Thank you very much. Questions? I wrote like questions and discussion, so you can also say that you have a totally different opinion and you don't agree at all. I'm totally fine with that. So, yes.
Thank you, Mark, for your talk. And I was interested in slide 34 with the washing machine, because you say like you look at the software as a black box, and then you detect the messages and try to figure out if something is wrong. So I see, for example, if the temperature is very high, then probably there is something, and you would try to notify the user. But I was thinking from a privacy point of view, for instance, like the software that was using the contacts for nothing at all. If you see that the software is using it or sending it, then would you be able to know that it's a problem or not? Because you have to know, like, it's a game, so it doesn't need it, and then you should stop it. But then can you really tell a lot of things concerning privacy just from the messages going out and in?
Yeah, that's a good question. The answer is I don't know. So this is something we are looking at the moment, if we can do it. My guess is that to a certain extent you can do it, because the underlying assumption here is swarm intelligence, more or less, so that we say, okay, what happens somewhere else? Is it different from what happens with me? Then it's probably not normal. Okay. But of course, it's unclear what is normal, because if you would want to... So another thing that we also look at is doing static code analysis, for instance. And so my approach is to say, okay, we do different things and try to combine it and then get the best picture that we can get. There's also like an initiative at the moment where they have specifications for hardware and software components that then define certain things. And I would again say, like, we can go to a certain boundary. We can say, okay, at the beginning, the software can do everything. With our solution, it can still do a lot, but at least we saved the people from the stuff that is around that. Thank you.
Thank you.
Other questions, discussion points?
Thanks, Marc-Oliver. I have two questions. So one would be about how do we stop DOS and DDoS kind of things here? Because that's the thing I see like weekly with my IoT platform. So that's the first one. The second one is, I think we also need, people who are trying to break into our system, so that we are aware of the tiny holes, because we as security engineers or researchers, we have to secure 100%, where a hacker just need to find 1% and they can break into our system. So how can we find a balance in that?
Mm-hmm. Thank you very much, Sumya. Very good. Yeah, so with the denial of service, when we go to the next slide, so when you have such functionality, then this is very helpful for the denial of service, because when you know the periodicities are typically like that, you can see denial of services, because then it will be going tremendously up, and then you can automatically block it. So there you can do something similar like you do with the web service today, that you just look at bursts and then you can stop that. And this is already helpful, plus the problem that Sumya was referring to often comes from not sufficient additional security means, so like no proper access control, standard passwords, and so on. And with the other tooling that I showed before, we try to exactly prevent that. So these would be the two answers to that. So we try first that you cannot enter the things to do malicious stuff, because also with the software update will be the typical thing. And so this one we also try to figure out that the software is not from one release to another suddenly doing something totally different, even though it's challenging, of course, because an update might change what is happening there. Okay, and second thing about the hackers. Yeah, I totally agree to what you say. And the message there is, do hacking, but be a white hat. So inform the people that you hacked afterwards that there is an issue, and most companies hopefully will be very happy to hear that, because indeed we need that, because the goal is, of course, what Sumya said. We want to have 100% security, but it's very difficult to achieve, because we are not. So why is it difficult to achieve? So especially because we have a distributed system where processes are running in parallel, and we have lots of side effects from these different installations being different. And we, even if we do the best software design, cannot anticipate that before having it deployed. And the reason is that the systems that we are creating there, they are not so easy, or like they're not at all formally verifiable. So you cannot verify this functionality from the start to the end, because it's just not possible to model it, because in the end you would have to model the world then, and this is still NP hard. And so therefore it's very important to have these people stitching the needle into something and then reporting, okay, there's still an issue, and try to fix it, then it's a little safer place. Thank you. Laura.
Yes, thank you for your presentation. I have a question about IoT, because this is really software-oriented, but how do you deal with the constrained nature of the object in terms of energy, of processing power, or the fact that an object may be here in all your drawings, the object was inside the house, but it can be on the field and can be physically.
Very good question as well. So, indeed, this is of course very challenging, because in my ecosystem here that I'm showing, this challenge is then here, because you have entities and then they're connected to a component where I have enough resources, and in the enough resources world I can do what I was describing here. But how do I deal with this here? And so my answer to that is, or my approach to that is, first of all, again, transparency. So I, as someone who is consuming data here in a service that is far away from what is happening here, and in terms of when you implement it like this, as loosely coupled system, also totally far in the term that it doesn't even know who was interfacing it and who was providing that. What I want to know as a service is, okay, how secure is it that the data is like that, and how did the data come here? Because of course what we can do is we can do encryption, not end-to-end encryption necessarily here, but we can do encryption from here to this end, then we can do encryption in here, and then we have a secured path that we didn't secure end-to-end, but if we trust the middle here, then we at least have some security. We could even do end-to-end security when you think about having a private key on the device, which is possible with co-processors, even energy efficient, and then at least signing the data or even encrypting the entire data entities, then you can indeed have end-to-end security if you know this key here. And so my approach is to say, okay, we try to have as much security at the edge as we can have by using HTTPS, for instance, or other protocols that provide, or layer 2 even, providing layer 2 encryption protocols, and then making it transparent. Okay, so this is data that is secured also from here to here, so you can trust this data more. But this is also a very interesting research topic, because it's, again, challenging. So this thing that is in the field, so for instance, the LoRa group is building a LoRa device, and it should be energy efficient because it will be battery driven, and as Laurent said in his talk, it's something that will run for years, or at least for a very long time, and therefore it has to be very, very energy efficient. And there, of course, you cannot do that. You cannot do continuous monitoring with machine learning algorithms on the LoRa device, because then the promise of the battery will not happen anymore. Like Alexander also showed, like, okay, so the device is not running forever. And with machine learning, as you know, is very compute intense. I was reading this one article that said, okay, it's the machine learning algorithms are using more power than multiple countries in the world today, because it's just so expensive to learn something. Of course, it's not running on these devices. But it's, of course, this is the key, what Laurent said. It doesn't bring anything if we have security here and then someone is hacking here, because then we can be as secure as we want, because the weakest part in the chain is determining like how secure we are. Thank you very much.
Oh, more questions?
So it's more of a discussion rather.
Sure.
So outside the boundary that we talked about in the presentation about, the awareness of privacy in people's eye, because I feel like we talk much about the importance of privacy and what the company would do if they have this data. It's of much value to them. But then, like, when we, I don't know, talk with friends or family, like, say how important I am just for someone to know where I am. It's okay, I don't care, like, for instance, like this. And I think it might be of a huge effect in our goal to ensure privacy, to, like, transfer this awareness to the people outside. So I don't know what are your insights on that, and is it something that we should approach, or we just try to protect people from the, as you said, by design, and not give enough effort for the external or, let's say, social part?
Mm-hmm. Yeah, also very, very important point. So what I always tell my friends is, of course, your communication, you might consider it unimportant, but now assume that you're suddenly deciding to run for American president. And then suddenly it becomes important, because then they're looking, okay, what did he do like 20 years ago? Oh, they are nice pictures, let's put them on the newspaper. Yeah. And the interesting thing is now, why is this possible? And the answer why this is possible is storage is extremely cheap. So you can just collect data and store it. You don't do anything with it because it's totally unimportant to look at it, because you're not important at the moment, but then suddenly you get important, and then they can just go to the archive and do something there. So storage is cheap, so they can analyze later. Plus now with the fuzzing, so with the machine learning where you don't have to explicitly program what you're looking for, you can just routinely do some analysis here and then find out things, and then suddenly you will become important. So the example there is again like when you do phone calls and you say certain keywords, then it's quite likely that they are looking at what you're doing there more in detail. And so this is what I would say is the big thing. And so this is also what I say when people say like, okay, yeah, I want to share everything because, I mean, it doesn't matter. It matters. So yeah, this will be my point.
Thank you.
Okay. Yeah, so I'm also happy to continue the discussion with you offline if you're interested. And I'm also talking about this, how our world is changing through the algorithms a lot with people. So I'll also do some interviews here on site today with some people. And when you go to the YouTube channel where we also put this, there are also interviews with some of the Turing Award winners, for instance, and also other interesting people. And the goal with these talks is talking with them, okay, how do you see this digital transformation? How do you shape it? How does it affect you? What do you think are the most important aspects? And this is one way of getting into contact with the people outside, because maybe someone is watching it and finding an interesting aspect. And I think the key is really communication. And also, I think it's definitely worth, when you do science, to also spend some time in communicating it in a way that other people can understand it, at least when you think it's something relevant for other people. And this is also something that is not happening enough today, I think. But luckily, what I see is that in the research landscape, at least in Germany, this interdisciplinarity is becoming more and more important, top-down, in the sense that they say, okay, if you do something with a social science department, for instance, you can get better money than if you do something with another computer science person. And so this is also an interesting development. I mean, I'm not happy with the implementation yet, because it still can be that then both are working on something similar but not collaborating. But it goes into the right directions. And here in Munich, this is also something where I was involved. We also have now the Bavarian Institute for Digital Transformation, which is also taking care of things in that direction. In Germany, we have also now an Internet Institute. And so they are looking at, okay, what happens to society with this digital technology, and trying to raise awareness there as well. So I don't know how it's in other countries, but I consider this a very good and important idea, exactly for what I said. If the technology is out, this is also why I put this example with the bomb. So the bomb is there. We cannot retract it. Even if the researchers decided then, okay, we didn't foresee this, we want to take it back. No, it's not possible. You cannot take it back. And if something is out, it's out. And therefore, we should have at least to discuss it before. I mean, I don't say we have to censor it by stopping it necessarily, but we have to make people aware of this is happening. You can also talk with us and discuss with us and make the rules and the policies. And this also, coming from your question, so thanks for that. So the policy framework is also the important thing. So we as a society have to shape the policies. And they are not independent of technology, but the technology cannot write the policies. So the society has to write the policies, and the technology then has to take care to implement the policies. And to enable the society to make useful policies, the society has to know to a certain extent what is going on. And this discussion is important. Okay. Thank you very much. Then the next part on the agenda is, I guess, that you're working in the challenges, indeed. So, yeah, then you can work now on the challenges, and we meet at 12 here in the plenum again for Nicolas' talk on the IoT standard approach and short-range radio. See you later.